And thank you for joining us for the second workshop as part of Aberystwyth Robotics Week online. We're today going to be using TinkerCad to have a look at circuits. This session is going to be run by Thomas Fern, who is a PhD student as part of the computer science and robotics research group. And I'm sure he might even tell you a bit about his PhD whilst he's going through, but the main, apparently not, the main focus will be introducing you to the circuit simulation within TinkerCad. There is some coding as part of this, but we'll be providing a link to where you can actually copy and paste that if you wish to. If you're on a separate device, then hopefully we've made the link easy enough for you to be able to type that in relatively quickly. If you do have any problems during the session, then please do feel free to ask questions in the chat, or if you go to the participants list, there should be a hands up option. And of course, you're more than welcome to use thumbs up at any point, or any of the other reactions if you want to get a bit of help. So at that point, I'm going to hand over to Thomas, who will hopefully guide us through a nice, easy steps on how to build up circuits using TinkerCad. So thank you very much, everybody, and I hope you enjoy the session today.
Okay, thank you, Patricia. Right, let's get started. So again, we're going to be using TinkerCad for this particular workshop. You won't be using the same tools as you used for the previous workshop. So we're starting from a completely blank page, so to speak. And if I share my screen, I'll show you an example of what we're going to create today. Desktop 3. Here we go. So this is what we'll be building today. It's quite a big circuit, but nothing too complicated, but we'll take you through step by step on getting all the pieces together onto the board, and then wiring all the bits up, and then finally we'll be programming it to do what we want. So as you can see, we've got a little remote control here, so you can get some ideas of what we're going to be doing this session. So without further ado, what I will do is we'll go back to the dashboard here. So I'll wait a few seconds for you to log in, get to the dashboard, and then what we're going to do is create a new project. So if I open up my chat box, then if you use the like button to let me know if I need to wait. I need to go to participants. Okay, is everyone okay for me to carry on? Oh, hold on, this just crashed. Sorry, I'm just going to reshare that. I had a bit of a glitch for a second. There we go.
Anna, are you able to hear what's going on, or are you having problems following the what's been shared?
I can hear, but we can't see very much, and every now and then it all sort of freezes, and then we seem to join in about.
Okay. What I'll do is in the dashboard here, I'll copy the link in to the chat.
I'm also going to share a link.
But Davey, I have to say, is links together and having fun. So we might see how it goes, but we may just drop out and listen. Yeah. Oh, look.
Okay.
So how do I save that so I can find it when I'm not in this meeting? Okay. Remember that.
If you click on the 3 dots at the chat, there's a save chat option.
Ah, okay. I will do that then, and then I'll have those, and I'll email them to Davey, and I'm sure he will much sooner spend more time asks than he would do it.
Okay.
I'm glad he's enjoying the use of TinkerCad at least.
Good, good. Okay. Yes, it looks like we have got a couple of technical issues there, but we have got the instructions
Boring long
online.
extended writing tasks. People online in the house, and it's not working. Thank you very much, though.
That's all right. We'll make sure the recording goes up so he can come back and have a look if the connection does drop. Okay, so what I'm going to do now is create a new circuit. And what we get is a very similar view to what we saw in the TinkerCad design section. But instead of shapes and scribbles, we have different electronic components that we can just add into the board. So I'll give you a run through of what's on the top deck here. We've got a fit to screen button, which may come in use later. As our board expands and we add more to it, we can fit everything onto the screen. And next to it, we can delete components. We've got our undo and move forward tool. We have our annotation tool, which comes in quite handy, especially when you share your designs with other people. And then you've also got the view and hide. If you're currently not working on something, then you can hide it from the project, but without deleting it. And on the right-hand side, we've got code. Now this will come in handy later when we start to program our circuits. So we haven't got anything programmable at the moment because we need to add in our components first. Next to it, we've got start simulation. So that's the equivalent of plugging in our computer and powering the circuit. And then hopefully at the end, we'll all be using the share button to show our different circuits. So I'm just make sure that everyone has the web page open with the list of parts that we need. If you're wondering where the link is, it's just in the chat box attached to Zoom. And it looks a little bit like this. So what we're going to do first is start adding in the components. So the first thing we need is a breadboard. Now we can search it using this little tab here, or we can list all the components that are in the tab here. So what I'm going to do to start with is just type in bread, and you can see that it comes up with breadboard. So we'll just click on that. And you do have different sized ones available to you. So we're just going to use sort of the middle sized one. And there we go. So that's our first component on the TinkerCad circuits board. Now, I'm not sure if people have used breadboards before, but it's essentially like a multi-way distribution board that you plug your power electronics in. So everything works from side to side. So we're looking at the breadboard on an angle at the moment. So we've got, I should just mention, to zoom out, you can use the scroll wheel on your mouse. And you have also got the fit to screen tool as well, just on the side here. But I'm going to be using the scroll mouse quite a bit. And if you left click, you can also drag the screen around to change the view. Okay, so the next thing I want is an Arduino. So I'm just going to get rid of breadboard from here and type in Arduino. And we have the little Arduino Uno, which is just here. So I'm going to left click and drag that into the project as well. So I'm just going to zoom out a bit. Okay, so what we want to do now is, to start off, we want to add in some LEDs so we can start getting the Arduino to control the LEDs and control the speeds of how they flash. So we can go back to this search bar up the top here and type in LED. Now the one we want is this two-legged one, this little red one here. And what we'll do, we'll add the first one in, and it can go anywhere you want. It can go up here, but don't put them in the topmost and the bottommost ones, because these are used to distribute power. So I'm just going to add them there. Now, when you let go of your mouse, you'll have this blue box come up. Now, if you click off it and it goes, don't worry, because you can click back on the LED to find it again. And this toolbox allows you to change the color of the LED. So if I click on it, we don't get a massive amount of choices, but we have got green, yellow, orange, blue, red, and white. So for this first one, I'm just going to choose green. And then what we can do is then add more LEDs. So I'm going to add this one a few spaces over. I'm going to change it to yellow. I'm going to grab another one. Oh, it's frozen. There we go. And we'll change it to orange. Grab another one. And we'll change it to blue. I'm just going to change that one to red, so because orange and yellow will look quite similar. Okay, so we've got our Arduino here, and we've got our breadboard and our LEDs. And you can see at the moment that we have a USB cable here. Now this would usually be plugged into our computer if we had physical components that we were working with. Now, if you remember earlier, I mentioned the Start Simulation button. If I click that, you can see that the USB plugs itself in. So this Arduino is actually running and is live at the moment. So we'll just click Stop Simulation so we can start plugging in our LEDs. Is everyone okay and they've got this far yet? I'll take the silence as a yes. Yep, good, thumbs up. Okay, so what we need to do now is connect the Arduino to the LEDs. So to do that, we need cables. So to route the cables, as we hover the mouse over these pins, you can see a little red square coming up. Now, what I want to do is head to the ground pin, which is just at the top left of the Arduino. If I click on the pin, you only have to click on it once, you don't have to hold it down. You can see a cable starts to appear. I'm just wobbling it around there. Now, if I connect that to this row here, we've got plus here and minus. So these show like a battery terminal. So I'll click on ground side there. So this whole row of pins is now ground. And just to make everything pretty, we'll change the color of the cable to black. Because red is positive, black is negative. So we've now got our ground connected up. We won't have to connect the positive side because the Arduino needs to control the positive side. But first of all, we'll connect the ground up. So I'll come over to this pin over here, and then we'll connect it a little bit further up, and we'll be connecting it to the left-hand side of the LED, which is the cathode. So we'll change that to black as well. So you can see how this is connected up at the moment. Now, what we'll do is we'll plug in the anode, which is the positive side. We'll click on that. And we will select a port on the Arduino to connect it to. So in this case, we'll connect it to pin 3. And we'll change the color to red to show that it's positive. Okay, so we're ready to start programming our first LED then. Is everyone with me so far? Hopefully. Yes, good, thumbs up. So we'll click on code. Now there's a few different ways to actually program this. We've got the block editor, which is one way we can do it. But I think for this workshop, what we'll do is we'll use the text-based editor because it's a little bit faster and I tend to like it a bit more. So we'll click on blocks here. And what we want to do is click on text. And I'll say, are you sure? Because it can get quite difficult, but mainly you lose what you've created in the block editor. So we'll click on continue. And here we go. What we get is a few examples to start this off. So this is the text that you should see. Now you don't have to get rid of the code. You can keep this code and then build on it. So what's happening at the moment is we've got the void set up. Now this is the little function which the Arduino runs once on startup. It's like the start sequence. And then just underneath it, we've got the loop. And this is what the Arduino does continuously as it runs. So at the moment, it's giving you a LED flashing example. But at the moment, we've got pin 13 being used as the LED. So what I think we'll do to start off with is change this to the one that we plugged into, which is pin 3. So what I'm going to do to start off with is we'll just get rid of the 1. So we'll have 3 changes to start with. So what it'll do, it'll turn the LED on, it'll wait for 1 second or 1,000 milliseconds. It'll then turn the LED off and then wait a second. So if you've done those changes, you can then click on the Start Simulation button just at the top here. And if we've clicked it, we should have a flashing LED. Has everyone got flashing LEDs? Thumbs up if you've got a flashing LED. Yes, we've got 1 flashing LED. Oh, and we've got another thumbs up. Brilliant. Now, if you have a quick look, you can see that there's a warning coming up on here. Now, the reason this is because we don't have a resistor in place. So we'd find that it would significantly reduce the lifespan of the LED because we're trying to send too much power to it. So we're going to modify our circuit ever so slightly. So basically we don't burn out the LED. So I'm going to click the Stop Simulation and just hide the code by pressing code. Now, what I'm going to do is I'm going to click on this black cable here, and I'm just going to press the delete key, or you could use the bin icon at the top left. There we go. So we've now got a gap in our circuit. So what we want to do next is go back over to the search bar over here, and we want a resistor. Okay, and it should come up as the first thing here. So what we're going to do, we're going to drag that into our circuit. Now you need to make sure that you have it aligned up correctly with the LED. So one side is just under the LED and the other side is on that negative row down the bottom. Okay, so it should be connected down the bottom on this row and on this row. Okay, so brilliant, we have a resistor. Now we need to change the value of it. So for this project, we'll use 220 ohms. Now you can change the resistance using that little blue box at the top here. So in here, I'll get rid of the 1 and type in 220. But kilo ohms is way too much. So we'll click on the drop down and we'll change it to ohms, which is this single round thing. There we go. Okay, so we've modified our circuit. I'm just going to zoom out a little bit. So if we click on the start simulation again, we should see we now have a very happy LED, and it should last for many, many years. Brilliant. So has everyone got that far at the moment? Thumbs up. Yes, awesome, brilliant. Okay, so one flashing LED, yes, that is great, but I think the more LEDs you have, the better it is. So what we're going to do is we're going to spend the next few minutes plugging in the rest of the LEDs. So I'll stop the simulation and you can start building the LEDs up as I'm doing it at the same time. So what we can do is we can use pin 4. We'll click on that. And we'll connect it to the right-hand side of the LED. Then what we want is another resistor. Now what we can do, I hope, is copy and paste. Now here's a little keyboard shortcut for you. If you right-click on the resistor that we just created, if you hold Control key on the computer and press C at the same time, you can create a secondary resistor which has exactly the same value. So we're not having to recreate all the steps all the time. So I'll add this, I'll put this in place next to the orange LED, or I think this could have been the yellow LED actually. So we'll put that in place. And then what I'm going to do is I'm going to copy it again. And we'll move it across to the red LED. And we'll copy and paste it again into the blue LED. Okay. So these are all now connected up to ground. What we need to do now is finish connecting the Arduino to the positive side of the LED. So we'll take pin 5 and we'll connect it to the red side. And we'll finally take pin 6 and we'll connect it to the blue one. And just to make it a little bit more pretty, we'll change the colors of the cables so we don't get them mixed up. Or if you wanted, you could also change them to the colours of the LED if you really wanted. I'm going to do that. Okay, so we've now got all our LEDs wired up. Has everyone got that far so far? Yes, brilliant. Okie dokie. So now we need to make some code for the rest of the LEDs. So if we head back to the code tab here, what we're going to do is we're going to modify this slightly. So we're making the code a little bit easier to manage. So what I'm going to do, if you don't want to type all of it out, we do have some cheat sheets on the website where you can use the example code that I've got. But what I'm going to do is I'm going to type mine out. So I'm just going to remove that for a second and remove that. So at the top, I'm going to create 4 lines of code, and this will tell the Arduino what pins are connected to the electronics. So we're going to have int space green LED space equals space, and then that is connected to pin 3, and it will have a semicolon on it. And what we're going to do is create 3 more lines identical to that, but we're going to change the name of this section to yellow LED, red LED, blue LED, and we'll change this section to the number that it's connected to. So we've got yellow LED connected to 4, and the red LED is connected to 5, and finally the blue LED is connected to number 6. Okay, and if you can't type as fast as I can, remember there is some code on the cheat sheet for you to have a look at. Okay, so that's all good. We've got those pieces now. What we're going to do is in this startup bit of code here, we're going to tell the Arduino what is connected, what it's connected to. So with computers, we have inputs and outputs. So LEDs emit light. So this particular component that we're plugging in is an output. So what we're going to type in is pin, and then all one word with a capital M, mode. Just like that. And inside brackets, we can type in our first LED, which is the green LED, comma, and then all in capitals, big capitals, output. Then we'll close our brackets and add a semicolon. And then what we're going to do is add the other 3 in there as well. So pin mode, yellow LED, output, sorry, butterfingers. Our third LED is the red one, so we'll add in red, and that is also an output. And our final one is the blue LED. And that's also an output. Okay, so we've told what pins are connected to the LED. We've told them what type of components they are. So here comes the fun bit now. We're actually going to program the LEDs and give them some times so we can get them to flash in different sequences. So, is everyone with me so far? Yes, awesome. Thumbs up. Brilliant. Okay, so we're going to start with the green LED first, or the left-hand side. So as you saw with the demo that we had earlier on, we could see it flashing for 1 second and then turning off for 1 second. What we're going to do is exactly the same thing, but we're going to change the speed of the flash. So what we'll do is we'll type in digital, and with a capital W, write, for writing. And then in the commas, we shall put the green LED. And then we'll put a comma, and then all in capitals, we'll put high. Now, I'm sure you know computers work on binary, so they work on zeros and ones, and the Arduino works exactly the same. So for this, our 1 and 0 is a high and a low, but if we wanted, we could use a 0 or a 1 too. So we've got the digital light. Oh, we need semicolon. There'll always be a semicolon missing. Then we want to give it the amount of time we want it to stay on for. So we'll type in a delay, and then in the brackets, we'll have 500 milliseconds, or half a second. We'll close the brackets, add a semicolon. So if we run this now, if I click the start simulation, what we would see is the Arduino being plugged in and the light staying on. Now, the reason it's doing that is because when it turns the LED on and it stays on for half a second, when it finishes, it runs back up to the start of the loop and does exactly the same process again. So what we need to do is introduce another 2 lines which tell the LED to turn off. So that's what we're going to do now. We type in digital write, and then in the brackets we want the green LED again, but this time instead of high we want to type in low. So we're telling it to turn off instead of on. And then just underneath that we want to type in delay, and we want it to turn off for, let's say, half a second. So it will be 500 milliseconds. Okay, so that's our first LED programmed. If we click the start simulation, what we'll see now is it turns on and off a lot faster than our original program did. So has everyone got flashing LEDs? Yes, brilliant. Okie dokie. So what we can do is we can copy and paste these 4 lines here directly under what we've just written. So we'll copy and paste that there. And what we want to do is change the green LED to whichever one you have next. So in this case, that would be my yellow LED, or it could be your blue LED. Okay, so if you've changed that and you click on Start Simulation, what we'll find is that we have 2 independently blinking LEDs. Hopefully that works. Okay, so now that we've got those two working, we can add the third and the fourth. So we'll click Stop Simulation. We'll do exactly the same thing again. And we'll change it to red LED. And then we'll do exactly the same thing again, but for our blue LED. Okay, so what we should now see is a bit of a sort of flashing sequence as it goes down the line. Hey, worked first time. There we go. And nothing blew up because this is virtual electronics, not real electronics. Okay, so now we've got our flashing LEDs and we've got our bit of code that runs it all. We can click Stop Simulation. So just to make sure, is that working okay for everyone? Shall I carry on? Yes, awesome, thumbs up. So it's all very well plugging in LEDs and making lights flash, but this is Robotics Week. We want to do some robots and we want to drive some robots around. So the Arduino can provide inputs and outputs. So we can take in readings from sensors and we can drive motors around as outputs. So that's the next thing we're going to do. If we close the code tab, get rid of the resistor that we had from the previous one, and we'll type in motor. Now we do have quite a wide variety of motors available to us. So I'm going to click on the DC motor here on the right hand side. I'm going to drag that in place. I'm just going to plonk it here. Now what we're going to do first is wire this up. Now with motors, it doesn't matter which way you plug them in, because if you change the power around, all it does is go in reverse. So we're going to plug one of these from the ground connector on the breadboard. We're going to plug it into terminal 1. Sounds like an airport. And what we're going to do is take pin 10 from the Arduino and we'll plug it into the second connector of the motor. So that's all it is. That's all we have to do with our motor. So the next part is getting the programming sorted, ready for the motor to move. So if we go back to code, and at the top, what we want to do is tell the Arduino what's plugged into the pin. So we'll create an int and we'll call it motor equals, and we're plugged into pin 10. Okay, so now we've told what it's been plugged into. We need to tell the Arduino whether it's an input or an output. So we'll type in pin mode again with the capital M, motor, and we want to have a comma, and a motor is also an output. So we'll add in output in full capitals, close the brackets and a semicolon. Okay, and what we want to do is, let's say we want the motor to turn on for 3 seconds and then turn off, and then we want to flash the lights. So to do that, we need to add the code at the top of the loop. So just under this bracket here and above the digital lights, this is where we'll add our motor. So So to turn the motor on and off, we can use digital light, exactly the same as the LEDs. But instead of the LED pins, we'll type in motor. And to turn it on, we'll use high again. And that's all in capitals. Okay. So as I said, we'll turn it on for 3 seconds. So we need to tell the Arduino how long to turn that command on for. So add in a delay. And we'll say 3000 milliseconds or 3 seconds. And then finally we want to turn the motor off so it's not continuously running. So to do that we'll use digital light again. And that will be for motor. And instead of high we'll use low. And that's all we need. So once you've typed that in and we click Start Simulation, we can see that there is now a revolutions per minute text on here, and we can see the motor starts to spin up. And we can see our LEDs have started to flash as well. So is that working for everyone? Yes, thumbs up, awesome. Okay. So on to the next step. If we've got a motor and we've got lots of different coloured LEDs, this at the moment is basically semi-autonomous. We've told it what to do, but it's running by itself. So basically with some applications we want to be able to control what we do with our circuit. So a nice example is Robot Wars. We want to be able to control the robots to fight each other in the arena. And these are done using a remote control receiver. Now, TinkerCad has also got remote controls built into it as well. So the next step we're going to do is we're going to map the different button presses of the remote onto different tasks that the Arduino can do, or the different code that we've developed so far. So I'm going to stop the simulation, and then we're going to move on to the next bit of building the circuit. So I'm going to zoom out a bit. Everyone okay to move on to the next step? Yes, thumbs up. Brilliant. Okay, so in the search bar, we'll type in remote. Now you'll see that two things come up. We've got an infrared sensor here. We'll need that. And then we've got the remote itself down here. So the first thing we're going to do is we'll move the remote in by dragging it in like that. And we also need the IR sensor on the top here. And what we'll do is plug that into our breadboard as well. Okay, so the reason we've used these two is we've got the remote itself, but we need a component for reading the signals that is coming from the remote. And this is exactly what this little sensor here is for. The remote works using infrared light. This is exactly what this sensor was built to detect. So these two will talk to each other. But first, we need to wire this sensor up. Now we've got three little connectors. I'll zoom in a bit so you can have a look. We've got power, ground, and we've got out. Now out is just another word for signal or read. So this sensor works on 5 volts. Now we're lucky because the Arduino also works on 5 volts. So we'll start on the 5 volt line first. So if I zoom out a little bit. Now if you have a look on the bottom row of the Arduino, we'll see it has 3.3 volts, 5 volts, and then we've got 2 grounds. So what we're going to do is we're going to click on 5 volts and we're going to move it along to this bottom set of rows here. Okay, and we've already got ground set up at the top here. So we'll change the colour of the cable to red for now, so we know what it is. And we're going to add a cable from power here all the way down to 5 volts. We'll change it to red. Okay, so our 5 volts is connected up. Next we want to go to ground, and we'll click on ground, and we'll move it onto this row here. I'll change that to black. And finally we'll have this output here. Now for this we will add it to, let's have a look, which one should we connect it to? Oh, let's just add it to 9 for now. Okay, and we'll change it to pink. Okay, so we've got a fair bit of stuff, a fair bit of code to program for this now. So what we're going to do is go to the code. We'll move that over slightly. Now we've got all our code at the bottom here. What we're going to do is at the start we're going to add in the bit which controls all the infrared signals. But to do that first we need to import what's called a library, which is basically a short script or page which does a lot of the code and decoding in the background. So to add in the library, we'll add in hash include, I'll put a space, and then we want a less than symbol on the keyboard. It's one of those. And we want IR, all in capitals. And then all in lower capitals, we want remote .h. And then we want to close it off with a greater than symbol. Okay, so we've now got our library connected. Now we need to tell the Arduino which pins that the infrared sensor is connected to. So to do that, we want IR, all in capitals, and then we'll type in receive, we'll just call it RECV, space, IR, receive, and then all in capitals, receive, pin. Okay, and then we want to close that and put the semicolon. And just underneath it, we want another line which will decode all the infrared information. And we'll just type in decode underscore results, and then space results. Okay, so that's all we need at the top. Now, inside the setup, we need to tell the Arduino what it's connected to, and we need to initiate the library that we mentioned at the top here. So if we type in IR receive, just like we had at the top, dot enable IR in. And then what we'll do is put a open and close brackets on there. Okay, so everyone following at the moment? Awesome. Yeah, if there's a lot to type out, we've got the code that you can copy and paste in on the website. So inside the loop now, we need to tell the Arduino to take readings from that IR sensor. So just at the top of the loop, we'll add in an if statement. So what this will do is it'll say, if it's this condition, then we'll do this instructions. So if the button is 1, then turn the LED on. Or if the button is 2, turn the LED off. So for that, we want to type in if IR receive dot decode, and then we want to open the brackets, and then we want to add the ampersand signal, which is shift 7, results, and then we want to add the 2 closed brackets. So one for the decode and one for the if statement. And then we'll add a curly bracket in this case, and that's just to the right of the P. So that's shift 1 over from P. Okay, so for the next line, we want to type in unsigned int value. So this will be the place where the value of the button that you pressed on the remote will be stored. And this will be results dot value with a semicolon. Okay, so we then want to close it off with a curly bracket. So all this is doing at the moment is decoding the results that you get from the remote and then storing it inside this line here. Everyone with me so far? Am I going too slow, too fast? Thumbs up? Okay, I'll keep going as I am. So what we can do now is add what we call a switch statement. So if the case is we have this button that's been pressed, then we want to do this action. So on a new line, we want to add switch, and then inside the brackets, we want to add value. Oh, my mistake. This needs to be just under that line. There we go, switch value. And then we want another curly bracket. Now inside here we can start writing our first instruction. In this case we're going to add case. Now on the web page we have a list of button values which are decoded by the infrared library. So I'm going to copy one of those from the web page, and it's all the value is 2,295, and then we'll add a colon in there as well. So what this will do is read the value from button 1. And what we could do is copy and paste the first LED instruction that we created. Okay, so we've got, if button 1 is pressed, then turn on the LED, turn on the motor actually for 3 seconds and then turn it off. And then just under that, to let the Arduino know that we've finished the instruction, we'll type in break with a semicolon. So I'm going to click on Start Simulation and check that everything's working. Oh, we do have an error. That's okay, because we are missing something. Just under break, we need to add in a curly bracket. And we've got another error as well. Let's just find out where that's coming from. Live demonstrations. Yep, I know what I've missed. So at the top here, we have forgotten to actually tell the Arduino which pin it's connected to. Sometimes it's the simpler things in life. So what we want to do is add an int, receive pin equals, and then we plugged it into pin 9. And add a semicolon. So this should fix all our problems. Hey, there we go. So hopefully what we can do is comment out the bottom code at the moment, and we can do that using the / asterisk. You can see that all the colors have changed at the bottom here now, and we'll take it to the last delay that we had, and that's with closing it off with a asterisk /. So all that does is stop everything that's happening inside that bit there. So if we click on 1 now, we should hopefully see our motor start to move. And there it goes. So that should go for 3 seconds and then stop. That's unusual. It hasn't stopped. Again, live demos. I've just remembered why. So we are in fact missing another piece. So under the break, we've got, need to stop the simulation for a second. We need to add under here IR receive dot resume with a open and close brackets and a semicolon. Now let's see if this little bug in the code fixes everything. Okay, so it hasn't started on startup, so we'll click on 1, and after 3 seconds, hopefully we should see that it stops. there we go. And we fixed our little problem. So all we had to debug was this little line down here that was causing it to stop, keep the motor going. So did everyone follow that little stumble there? Yes, brilliant. Okay, so what we can do now is, now that we've got the fiddly bit out the way, is we can add more of these case statements that we have here. Now this is quite a simple thing to do because we have a lot of the code already made for us that we wrote earlier. So our first button was enabling the motor. So what we'll do under that break, if I stop the simulation first, is we'll add in another case, and what I'll do is copy and paste the value from button 2 off the web page, which is 34,935. We'll add a colon, and what we can do again is we can take the code from the green LED and we can copy and paste it into the case statement. Now it doesn't matter if the formatting or the indentation changes because it doesn't actually affect the functionality, but it makes the code a lot easier to read and then maintain. So after that, we'll add a break, and just to test it as we're going along, we'll click on Start Simulation. And now if we click on button 2, our green LED should start up. And it does. There we go. We had one flash from it. And if we ask the motor to move, we've got it moving there as well. So the next things we just need to do are add the rest of the LEDs. So for that, I'm going to stop the simulation again. We'll add another case, and the value for button 3 is 18,615. We'll add a colon there. We'll copy and paste the code for the yellow LED and add it just underneath the case. And just underneath here, we'll add in the break to tell it that it's finished. So we'll test it again with the start simulation. We'll click on button 3. And our yellow LED that you saw just lit up there. Our green. And our yellow. Great, so now we just need to add the other ones. So we'll add in another case for the red LED, and button 4 is 10,455. We'll add another colon there. And we'll copy and paste the code for the red LED. Copying and pasting, isn't it a wonderful function? And then we'll add the break just underneath it. We'll do a quick test for button number 4, should be red, and there we go. And then we'll add our last LED just underneath it as well. And button number 5 is 43,095. We'll add a colon at the end, and we'll just add our last bit of code for the blue LED. And then finally, we'll add the brake in there as well. And now we should have a fully working motorized LED flashing circuit. So we click on number 5, we've got our blue LED. Click on number 4, we've got our red. Number 3, yellow. Number 2, we should have our green. And finally, number 1, we've got our motor. We do have a actual simulated robot of a physical robot that we use for the Robotics Club, which is this little robot here, which will be loading in a few seconds. So you can actually make some really nice, more complex circuits to simulate real hardware. And this little robot here has exactly the same hardware as that. So you can test all your code out and you can run it on the TinkerCad workshop, and then you can actually execute it live on the real robot, because this one's got all the servos, ultrasonics, sensors. So it really is a nice, powerful tool. There you go. So hopefully that all works. I'll let you have a bit of a play with the rest of TinkerCad now, but that's all I've got prepared for this workshop. If you have missed sections or want to come back to how to add different circuits or different sensors, then you can come back on the recording. So I'll finish this share screen now, and I hope you enjoyed everything. Oh, we've got a virtual clap. Thank you very much.
Thank you, Thomas. That was very nice.
Thank you. Yes, little fumble there, but live demos. What could possibly go wrong?